TSA is a group of technology students, and we have a chapter here in Litchfield. There's also a state affiliate and a national affiliate. We've competed at the state and national level over the years. Each year we get together and go to the state conference, and over the years I've actually taken kids to 4 national conferences in Orlando, Florida, in Tennessee, and in Atlanta, Georgia. The whole idea is that the students can get to do classroom type activities and then take those classroom activities and transfer them to a competitive setting where they're going to be working against other students here in the state of Connecticut or on the national scene when we go to the national conferences. The ones that the kids seem to enjoy the most are the CO2 cars. We always make a showing with the computer-aided design component, and over the years we've done quite well in that area. There's a quiz bowl, there's a bridge building contest, or sometimes it's a tower building contest. There's a problem solving contest. The last conference we went to, we swept the problem solving. We took 1, 2, and 3. We're asking the Education Foundation to fund the purchase of 4 laptop computers so that we can take these computers to the conferences and the kids can use them in their competitions. They can also use them to prep before they actually go to the competitions. They can load the software in. They know how the machines are going to react. They can put all the information on them that they'll need for their different competitive events. The competitive events that we enter into are a low-level systems control technology competition where students program Legos and then get them to function according to a task that they're given when they get to the conference. The other large component that would involve computers would be the computer-aided design and computer animation competitions that the students compete in. We would be doing both these on the state and national level. And when it comes to going to national conferences, the laptops are essential. We can't be lugging desktop PCs down all over around the United States. And even within the state of Connecticut here, it makes it so much easier when we have the laptops for the kids to get in, get set up, and get up and running for their competitive events. We've made the full generation move from 2D drafting on a computer to actually working in the computer in 3-dimensional space. The students are using state-of-the-art programs within the AutoCAD suite. At the moment we're using Revit, which is architectural drawing software where students actually build a house in 3D space, and then from that model that they build, they can then generate the different drawings that are involved in the completion of an architectural structure. The whole architectural field is moving towards this model at this point in time. As a matter of fact, I do some adjunct teaching at a local community college, and I have architects enrolling in my course there using the Revit software so that they can get up to speed and be up and running for their particular areas or disciplines where they're working. The other areas that we're working with the 3D modeling is a mechanical, and we're using a program known as Inventor. There's another one on the market called SolidWorks. Basically, SolidWorks and Inventor are the same thing. They just do it a little bit differently. Here, rather than building structures, we're talking about building components that would go into like a car, machines. But it's basically what we would call the machine drafting. In the old days, what we did is we thought in 3D, drew in 2D, and then generated in 3D. Now what we can do is we can actually generate in 3D, pull the necessary drawings off, or in some cases what's happening is the components aren't even being drawn. They're actually going from 3D in the computer to 3D on the machining end, so that there's never any 2D generation needed in between. The other area that we're looking to move into would be the computer animation, and next year I hope to be up and running with a program called Maya, and we're going to be putting that into our communications course here at the high school.